Hey guys, here's a quick video on domain and range. So first of all, let's just start with the basics. Let's say you have a number line and you have something like this that goes from here to here. The way we express this in interval notation is 1, 3. And because these are open circles, that means it doesn't include 3 and it doesn't include 1. It includes the numbers that are just a little bit bigger than 1 and a little bit smaller than 3. So it would include 2.999, but wouldn't include 3. Now, what happens if I go in here and I fill in these circles? Or let's say I fill in this one. Now that includes 1, and so we change that to a square bracket. Now, let's say I fill in both of them. Then that becomes square brackets on both. So that means all the numbers between 1 and 3. Okay, so domain and range, let's say you have something like this. Let's go in 2 dimensions. And we have some kind of thing like that. And let's say this is 1, let's say this is 6. The domain measures how far to the left and how far to the right we go. So we'd say 1, 6. Now because this is filled in, we use a square bracket. Because this is open, we use a rounded parentheses. Now the range is a measure of how far down and then how far up it goes. So here I'm going to test this and then I'm going to test this value right there. Let's say this is 3 and this is 9. I'm going to do 3, 9. Now it doesn't matter that it dropped back down to, let's say, 7 or something. Domain and range is just a measure of the extremes. The extreme low is 3, the extreme high is 9. Kind of like if we package this up into a box. Domain is how far to the left and how far to the right the box goes, 1 and 6. And range is how low, which is 3, and how high, which is 9. Now 3, this was a filled in circle, so it gets a square bracket. Now 9, right here, there is no circle at the top of this curve. So you can't tell from the graph whether that's 8.9999 or whether that actually gets up to 9. So as a practice going forward, we always give that the square bracket. And the reason for that is because it's easy to write an equation that will hit the 9 and go back down. It's really hard, if not impossible, to write an equation that gets infinitely close to 9 and then backs back down. So domain range, domain left and right, range up and down. Now, next thing I want to talk about is something like this. What if there is a hole or some kind of a gap in it? Let's say we go something like this, and then let's say we do something like this, and let's fill this one in. So let's say this is 2, and let's say this is 7. Well, over here, if I keep on going left, I will eventually get to negative infinity. And if I keep on going in this direction, I'll get to infinity. So negative infinity is our left bound for the domain. So it's going to be negative infinity all the way up to 2. Now 2 is an open circle. It's not filled in, so it gets a rounded parentheses. Now on this part, you have 7 all the way to infinity, and this gets a square bracket. Infinity will always get the rounded parentheses. Now the way you join those two sets together is with a great big U, union. So we combine those two sets. So this is how you would write it. And you would write it even if the hole was really small. So let's say you had something like this and a hole and something like this at 4. Then you would say the domain is from negative infinity to 4, union 4 to infinity. Now another way you'll see this sometimes is just this. X is not equal to 4. So you can say, or sometimes it'll be something like X is all real numbers but not 4. This is the way we're going to be writing it in this class. Okay, now let's talk about whether something is a function or not a function. So a function is a rule that assigns to every x value 1 and only one y value. So if I have 2 repeated, and now this times 2 is going to 7, this is not a function. Let's look at it this way. If I have 2 and it's giving me 8 and it's giving me 7, that is not a function. And the reason why it's not a function is because you can't write it as a f of x equals with some kind of expression here involving x. You just cannot write it that way because x goes into the machine and somehow it produces two different y values. Now there is a way to do that. For example, you could have something like xy equals x squared over y, and this would make something like that. But you couldn't write it as a y equals x something. This would be not a function. Now, how do you tell on a graph if it's a function or not a function? On a graph, let's say you have something like this. This would not be a function. Why? Because if I pick some number here like 3, and I put this in a table, if my x value is 3, my y value is 7 and -2. So 3 would go to 7 and 3 would go to -2. On a table, you'd have this repeated x value, and that repeated x value would mean that it is not a function. Okay, let's see if something like this is a function. Function or not a function? And the answer to that is not a function. And the way you're testing at this point is with something called the vertical line test. If a vertical line cuts through at 2 points, that makes it not a function. Now the question is, when you have something like the rational functions we're dealing with, which is 1 over x minus 1, and you have a graph, then right here at +1, I have a horizontal asymptote. On this side, I'm going to be going down, and this side, I'm going to be going up. Now at 1, this function is undefined. So the question is this a function or not? And the answer to that is, number one, we have to first establish what the domain is. The domain, we talked about it as all the x values. Here we're going to be a bit more precise. Domain are all the x values that the function can handle. Okay, in other words, where it makes the function defined. So here, the function is not defined when x is 1. And so we say 1 is not part of the domain. So now the question, is this equation a function or not? You have this point right here. At this point, if my x and y table, if I plug a 1 into my table, 1 in this way is going up to infinity, and 1 is also going to -infinity. So immediately you'd be like, well, it's not a function because 1 produces two different outcomes. But domain are the x values that the function can handle. It can't handle 1. So 1 is not in the domain. Now, why does this matter? Because now we can say, yes, this is a function on its domain, and that domain doesn't include the value that makes it go crazy at. It doesn't include 1. So when we look at things and decide if it's a function or not, you have to decide if something is on the domain. So, for example, if I have something like this, is this a function? And the answer to that is yes, because every x value has only one y value. But if I color this in, then the answer to that would be no. And if I have some function like this, or some graph like this, is this a function? Well, it is a function on the domain that excludes this line. So excluding x equals 0, it is a function. It is a function on its domain, and its domain excludes the values that make it go crazy. Okay, that's it.